Hello, so this is just a video going over the notes that we did on Thursday the 14th, in case you did want a little bit more practice converting from radians to degrees. So on here I'm going to start on slide 1, but if you want help with a different slide, feel free to skip ahead. So starting with slide 1, this was the warm-up. We're asked to identify or find the value of angle x. So angle x is this pink angle here, and it starts on the x-axis and it goes up to this little diagonal line. Now the angle that gets created is in here, and we need to find out what is that angle. What's the value of that angle x? So how we can do that is we want to go based off of the xy plane, meaning the axis points here. So I want to look at the y-axis and the x-axis. So if we start here at the bottom of our x-axis and we work up in this direction, this shape here, just this first quadrant L, is 90 degrees. And actually each quadrant will be 90. So the first one is 90, but let's say we wanted to do the entire, let me get rid of some of this. From starting point, let's pretend we went all the way around and made a flat line. So a flat line is 180 degrees. So that orange flat line I just highlighted, that would be 180 degrees. Another way you could potentially come to that value is you would say, okay, each quadrant is 90. So if the first one is 90, the second one is 90, 90 plus 90 is 180. So the two quadrants together are 180. Adding another 90 to 180, we can come up with the value of that third quadrant, 7, 2, which is 270. Adding 90 to 270, 7 will be 16, is 360 degrees. So what that means, it's basically saying, okay, if we started at the starting point, which is what I'm highlighting in orange, this is always our starting point. If we went up here and landed, that would be 90 degrees. If we went past that but landed here, that would be 180 degrees. If we went past that and landed here, that would be 270 degrees. If we went past that and landed back at our starting point, that would be 360, which is a full circle. Okay, so now that we know the degrees of each quadrant, let's use that to find the value of angle x. So in order to do that, imagine this pink angle, imagine this pink arm here got cranked all the way down flat, right? Then that angle would be 180 degrees because the flat line is 180 degrees. However, it's not down flat there. Instead, they're saying we have 75 degrees of space here, basically. So in order to find exactly what this pink angle is, we're going to do 180 take away 75 degrees. So that's like saying it's almost that flat line, but it's short by 75 degrees. So I'll tell us what the full angle is now. 105 degrees. So then we can conclude that the pink angle, I'm going to get rid of all of this stuff. The pink angle here is 105 degrees. And notice 105 is larger than 90, which makes sense because this angle goes past 90. But it's shorter than 180 because the line isn't quite at 180 yet. Okay, if you want, go ahead and pause the video and try the second one on your own. I'll do it in just a second, and then when you're ready, you can start the video again. Okay, so for this one, same thing, you want to label each of your quadrants. So just the first is 90, the second one is 180, the third one is 270, and the last one is 360. And eventually you will get to a spot where you can memorize this, but it's okay if you don't for now. You can always look back at your old slides. Okay, and we're trying to find this pink angle X, and this actually starts here at the bottom and goes all the way around to right here. So this angle, notice it's almost a circle. And in order for it, or if it were a full circle, it would be 360 degrees and come all the way around here. But it's not, it's short by 55 degrees. So we're going to do 360 minus 55 degrees, like saying it was almost a full circle, but it's short by 55 degrees. And I got 305 degrees. Okay, this next one, I'm not going to go through all of the slides, but this next one is slide 5. The whole Fahrenheit and Celsius conversion will not be on your test, but I just wanted to go over it in case you were curious. So we're given this formula here for how to convert from Celsius to Fahrenheit. So I'm being asked to convert 6 degrees Celsius. We want to know what is that in degrees Fahrenheit. So in order to do that, I can replace the 6 degrees Celsius. I'm going to put a 6 here in this formula where the Celsius is. So the Fahrenheit will equal 1.8 parentheses, and that's where I'm going to put the 6 plus 32. Next, I'm going to multiply the 1.8, multiply it times 6. And I got 10.8. And you just bring down the plus 32, and then to get the final Fahrenheit temperature, we're going to add those. 10.8 plus 32 is 42.8, but definitely check my math there. So that is saying basically that 6 degrees Celsius is 42.8 degrees Fahrenheit, or we can round that to 43 degrees Fahrenheit. Okay, so now we're finally at the main point of the lesson, which is converting angles from degrees to radians. So angles can be measured in either a degree or in a radian, which has a pi. So what we're practicing today is converting between the two. So I'm on slide 7. That one says convert 60 degrees to radians. So we want to convert 60 degrees to radians. And actually, before we do that, I should have mentioned something else. In order to convert degrees to a radian, you always multiply by pi over 180 degrees. And pi, notice, is going to be in the numerator because we need pi to be in the radians. So in order to convert from a degree to a radian, you always multiply by pi over 180. So here the example on slide 7, we want to convert 60 degrees into radians. So what is 60 degrees in radians? So what we do is we take that 60 degrees, and I'm going to multiply it by pi over 180. So multiply by pi over 180. Now when you do that, you actually just multiply straight across, numerator with numerator, denominator with denominator. And you don't even have to multiply by pi, you can just write it, 60 pi, like that. 60 times pi, we're just going to write 60 pi. 1 times 180 is 180. Cool, so I'm on my first step of converting that degree to a radian. Now I just have to reduce the fraction. So I'm going to reduce 60 pi over 180. So a little tip, so how you reduce is you want to basically divide until you can no longer divide the numerator and the denominator by the same number anymore. Looking at 60 and 180, I'm seeing right away I can actually divide both of those by 10, which is the same thing as just dropping that 0 on the end. 60 divided by 10 would be 6. And then you keep the pi, over 18. If you're confused as to what I did there, technically my first reduction was dividing by 10. Divide by 10, divide by 10. 60 divided by 10 is 6. 180 divided by 10 is 18. So now you're still trying to reduce this fraction, which means you're just dividing by the same number until you can no longer divide by any numbers anymore. And the bigger the number, or if you can get the greatest common factor or the greatest common divisor, then you will only have to reduce once. Meaning that I'm going to go ahead and divide both of these by 6. 6 divided by 6 is 1. And again, we can just ignore the pi and bring it along at the end. 18 divided by 6 is 3. And that is as far down as they can be reduced. We can't divide by anything else anymore. The only number we would be was 1, but that would get us the same answer. So then that is our response. 60 degrees is 1 pi over 3 radians. So you always, always, always multiply by pi over 180 and then reduce. Slide 8 is the same thing. The same directions are on the side where we are going to need to convert from degree to a radian. And in order to do that, we always multiply by pi over 180. Okay, so then on slide 8, it says convert 360 degrees to radians. So I'm going to multiply 360 degrees times pi over 180. Remember here, you do just multiply numerator with numerator, denominator with denominator. And you should get 360 pi over 180. Then from here you do reduce, which is just dividing by your common factors until you can no longer divide anymore. So if you'd like, go ahead and pause the video, go ahead and try reducing, and then press play when you are ready for the answer. Okay, and then I am going to go ahead and divide by 10 right away, which is just 36 and 18, and I bring along that pi at the end. 36 and 18, I can again divide by 9. 36 divided by 9 is 4. 18 divided by 9 is 2. And again, you may have not divided by these exact numbers. Maybe you did 2, 4, or 5. That's totally fine. As long as you're getting whole numbers and not decimals, that's fine. We'll eventually end up at the same response, or we should. So now I have 4 pi over 2. I'm just going to rewrite it here. Kind of move it out of the way a little bit. Oops. And I can still keep reducing this. I can divide 4 and 2 again. I could divide both by 2. 4 pi divided by 2, or 4 divided by 2 is 2. Keep the pi. 2 divided by 2 is 1. Now I can no longer divide because I arrived at a 1. If you arrive at a 1, you're automatically done. And 2 pi over 1 is actually the same thing as 2 pi. Remember, if the denominator is 1, you can drop it and make it invisible. So 360 degrees in radians is 2 pi. Okay, next we're going to go over slide 11, which is pretty much doing the reverse. So we just practiced converting from a degree to a radian. Now we're going to do the opposite. We're going to be given a radian, which is going to be something with some sort of pi in it, and we're going to be asked to convert it to a degree. And how we would do that is pretty similar to how we converted the other way. So remember, to convert from degree to radian, we multiply by pi over 180. To do the opposite, we're going to always, always, always multiply by 180 over pi. So it's the flipped or the reciprocal fraction. So to go the opposite way from radian to degree, you're going to multiply by 180 over pi. So then on slide 11, we see that we want to convert 3 pi over 2 to a degree. So this is a radian because it has a pi, and I want to convert it into a degree. So I do that by multiplying by 180 over pi. So I'm going to take this radian, 3 pi over 2, and I'm going to multiply by 180 over pi. So notice you're either multiplying by 180 over pi or pi over 180, depending on what you want to do. When we do this, same thing, we're going to multiply straight across, numerator with numerator, denominator with denominator. But before we do that, we can actually cancel out these pi's. And that's what we want. We're converting to a degree. We no longer want that radian pi. So now I have 3 times 180 which is 540. And 2 multiplied by nothing here, so it's just that 2 across, or like 2 multiplied by 1. And then from here, same thing, you can reduce. So you'll say, okay, I can divide both of these by a 2 because they're both even. 540 divided by 2 is 270. And I am doing all this in a calculator, so feel free to use a calculator. And 2 divided by 2 is 1. And then we can just drop that invisible 1 denominator and say that it's 270. So convert 3 pi over 2 to a degree, it is 270 degrees. Okay, so go ahead and try slide 12. It's going to be the same thing, multiplying by 180 over pi. When you're ready to go over it, press play. I'm going to quickly do it. Slide 12. Okay, and actually I'm only going to do the first one for slide 12. So we're converting 1 pi over 2 to a degree. So then we multiply by 180 over pi. And one way that helps me know, like, okay, which one to use when, is I know when I want to end up at a degree, I need the pi's to cancel out. So that means that pi is going to be in the denominator for me, so it can cancel with the pi in the numerator here. So that's how I typically remember. I'll say, okay, degree, radian to degree, the pi's got to be in the denominator. Okay, so I take this radian, 1 pi over 12. I'm going to multiply it times 180 over pi. I'm going to cancel out the pi's, multiply the numerator straight across. 1 times 180 is 180. 2 times 1 is 2. And then I'm going to reduce that fraction. 180 divided by 2 is 90. 2 divided by 2 is 1. 90 degrees. So 1 pi over 2 in degrees is 90 degrees. And then for the remaining slides, so slide 14 and 15, you have to basically decide which one you want to use. So if you're converting from radian, I'll write it here, radian to degree, you want to multiply by pi 180 over pi. Okay, you want to end up at the degree, so the pi's got to cancel. If you're doing from degree to radian, sorry, I know my handwriting is getting sloppy, then you multiply by pi over 180. And a way to think about it is, okay, if I want to end up at the radian, that means I need a pi on the numerator because radians have a pi. Okay, so radian to degree, you multiply by 180 over pi. Degree to radian, you multiply by pi over 180.